All right, what we're going to talk about here is the reflections on a graph and what that looks like and how you know it happens. So we're going to start by plotting these points. Let's do, on our axes, let's do 3 up and down, 3 left and right. And then what I want you guys to do, I want you to plot these 2 points and draw a segment. So -1, 3. 2, 0. And then we're going to draw that line segment. All right. Now what I want you guys to pay attention to is this notation here. We have f of negative x. Now, is this negative x part of the input or the output? The input. We're actually going to be plugging it into the function. But with that said, if we have f of negative x, what we're doing is we're just changing the x values. What we're going to be doing is changing the x values to their opposites. So let's go ahead and do that. So instead of -1, 3, we're going to have
1, -3.
1, careful, just the x.
Oh, so 3.
1, 3. And then instead of 2, 0, we're going to have -2, 0. And let's see what that looks like. We have 1, 3 and -2, 0. And draw that segment. So what we did is, for this function, we plotted f of negative x. And what happened to our graph? How does it compare? Not perpendicular. The x values are opposite. It reflects over the y-axis. Excellent. Okay, so there's a reflection over the y-axis. Notice this was our original graph, and this is an exact mirror over the y-axis. When does that happen? When we're inputting a negative x. Okay, so the graph of the function can always be obtained by just doing a reflection over the y-axis. Okay, so anytime you have the opposite x values, you're going to do that. Now remember, we have kind of done stuff like this before, and I said, oh, if I have an x here, right, then the opposite x value, if this is a point on my graph, the opposite x value is going to be over here. That's a reflection over the y-axis. Okie dokie? Okay, so now we're going to look at the opposite of f of x. So is this changing x or y?
Y.
This is going to change y. So we're going to come up here, and we're going to actually change the y coordinates. So instead of -1, 3, we're going to have -1, -3, and instead of 2, 0, it stays the same, right? 2, 0, because the opposite of 0 is just 0, and we'll plot those. So we have 2, 0, and -1, -3. Now we're going to be comparing to the green graph here. All right, what do you notice here?
Oh, it's parallel. Wait,
It's what?
Is it?
Yeah, so it's going down here. It's reflecting over the x-axis now. Okay, so anytime you have the opposite y's, all right, gives you a reflection over the x-axis here. All right, but that's what this is. Opposite of f of x, you're changing all the y values. Where there was a y, there's now the opposite y, so that's going to reflect over your x-axis. So that's what these mean. All right, and now let's take a look at some graphs to put it into practice a little bit here. Okay, we have a function root x. Okay, so our parent function, I'm going to draw 4 tick marks to the right, 2 tick marks up. And we know for root x we have 0, 0, 1, 1, 4, 2. How do you know that so quickly? Because you have it memorized. That's right. So this is g of x. All right, so g of x equals root x. All right, but now we need to sketch g of negative x. Is this the input or the output? Input, right? So if you're changing the input, all right, of our x, where we once had an x, we now have a negative x, so the reflection is over the y-axis. So now I have 1, 2, 3, 4. Instead of going right 1, up 1, I now go left 1, up 1, and left 4, up 2. And this is g of negative x. Okay? If I have g of negative x, what does my equation actually look like? So I did have root x. What would be my new equation?
Negative root x.
But if I have negative root x, is it on the inside of my function or on the outside?
Right?
Right, but what is this?
This
This is the inside.
Square root negative x.
You bet.
I thought you could do that.
We can.
Oh.
And this is what the graph looks like. We can't do the square root of negative 2, but what would happen is all my x's need to be negative, so that gives me a positive y value.
Oh.
Make sense? All right, so this is what our graph looks like. This is what it looks like to have a negative on the inside of your parent function. The negative would be with the x value. So then we come over here. We're going to go ahead and sketch h of x. Okay, so this one you guys should have pretty down. 0, 0, 1, 1, 2, 4, reflect, do. Okay, so here is h of x equals x squared. All right, here is the negative on the input or the outside of the function. This is on the outside, okay? And because of that, where is the reflection going to be?
X.
Over the x-axis. All right, so normally we go right 1, up 1. Now we're going right 1, down 1. We have all opposite y values. Oh, that was an awful graph. That curvier. There we go. All right, now what does the function look like? So I have negative h of x. So the opposite of h of x equals, what would that look like as our function? So we started with x squared. Now we have
X squared.
negative x squared. So that's on the outside of our function. Any questions about reflections?
No.
No?